The next transformation is perpendicular bisector line. Now, perpendicular bisector means if you have 2 points A, B, and the perpendicular bisector of AB is a line that passes through the midpoint. Midpoint. That's why we call it bisector, and perpendicular means makes 90 degree. That's why we call it perpendicular. So perpendicular bisector line is this line. This is the perpendicular bisector line. Now, the transformation of the complex number would be in this format. Modulus of z minus a1 plus b1i equals to modulus of z minus a2 plus b2i. So that would be the format for perpendicular bisector. It means the locus. This is also locus because it is equidistant from A and equidistant from B. Any point on the perpendicular bisector line is equal in distance from A then to B. And so that means if you have 2 points A1, B1 and another point A2, B2, then this line is going to be the perpendicular bisector of that A1, B1 point and A2, B2 point. This is what it means. So let's do this. Let's do an example. So suppose you have on one side, we have absolute value of z plus 4 minus 2i, and the other side we have z minus 8 plus 2i. First of all, we have to change the format because it has to be z minus complex number. So let's change this. We have to write z minus, so plus 4 would be minus 4 and minus 2i would be plus 2i, so that when you remove the bracket it becomes the same as before. So this is going to be z minus, so this is going to be 8 minus 2i, so that when you remove the bracket it becomes minus 8 plus 2i. Okay, so what are the points? So obviously the points that we have to bisect are minus 4, 2 and 8 minus 2. So I'm not plotting this yet in the x-axis y. I'm just giving you an idea. So what we have to do is find the perpendicular bisector of this line, so that it passes through the midpoint and it is perpendicular. So in order to do that, the best thing to do is to find a Cartesian equation. Now how to do that? Pay attention over here. The first thing that we have to replace is, let's replace z with x plus iy, and then we can find a Cartesian equation very easily. So if we do that, it is going to be x plus iy minus, if you open the bracket, it becomes plus 4 minus 2i equals to x plus iy minus 8 plus 2i. If you open the bracket, let's bring the real portion together. So x and 4. So x plus 4 is the real portion. If we take I common, y minus 2i, that's the imaginary portion. Similarly, x minus 8 is the real portion. Y plus 2 is the imaginary portion. Now we have to remove this modulus sign, which basically is, if you have a real portion and an imaginary portion, suppose a plus ib, then the modulus is square root of a squared plus b squared. So that's what it is. So if we remove the modulus, it is going to be square root of x plus 4 whole squared plus y minus 2 whole squared, and this is going to be square root of x minus 8 whole squared plus y plus 2 whole squared. Now if we send the square root to the other side, it becomes square. Square root of square is 1, so we can just remove the square roots. So x plus 4 whole squared plus y minus 2 whole squared equals to x minus 8 whole squared plus y plus 2 whole squared. Now if you break this down, it turns out to be a squared plus 2ab is 8x plus 16 plus y squared minus 4y plus 4 equals to x squared minus 16x plus 64 plus y squared plus 4y plus 4. So by algebra, this x squared cancels out with this x squared, this y squared cancels out with this y squared, and we have this 8x plus 16x, and that turns out to be 24x. And on the other side, we have this 4y and this 4y added together. This is 8y, and this is, we have a 4 over here and a 16 over here, which is 20, and we have a 64 over here and 4 over here, which is 68. So we have plus 68 minus 20, and that turns out to be 24x equals to 8y plus 48. Now we can further simplify by dividing both sides with 8. This turns out to be 3x equals to y plus 6. Therefore, y equals to 3x minus 6 is the equation of the perpendicular bisector line. Now you can sketch y equals to 3x minus 6.